Hey guys, and welcome to your next video on systems of equations and inequalities. This lesson is solving systems using the graphing calculator with matrices. So our learning target is I can solve systems of equations in 2 and 3 variables using matrices. If you like matrices, raise your hand. Me. So when we talk about matrices and solving a system with matrices, we have a fun new term to look at. Matrices that represent the solution of a system are in what we call reduced row echelon form. That's reduced row echelon form. Say that 3 times fast. Our graphing calculators have a RREF, Reduced Row Echelon Form, function for working with matrices. So yay for the TI-84, which can put a matrix into Reduced Row Echelon form for us. And we're going to take a look at how that works. So the first thing we need to look at with our problem here is, it says what is the solution to the system of equations. I want you to notice that there are 1, 2, 3 variables in the problem. There are A's, there are B's, and there are C's. Notice that all of the equations are set up so that the A's come first, the B's come second, the C's come third. A, B, C, A, and then this one doesn't have a B, but notice how we left that space there? That space matters in C. Also notice that all the equal signs are lined up. And the constant term, that's the terms that do not have a variable, all these constant terms come after the equal sign. This is called standard form of an equation, and the equations have to be in standard form in order to set the problem up, or to represent the problem with a matrix. So I'm going to set up what's called a coefficient matrix. A coefficient matrix expresses the terms of the equations in matrix form. So here's how it works. I take my first equation, 2a plus 3b minus c equals 1, and I'm going to write all of the coefficients of those terms in the first row of the matrix. So the coefficient of a is 2. There's my first term in the first row. The coefficient of b is 3. So there is my second term in the first row. The coefficient of c is -1. Remember, if we don't see a number there, it's a -1. -1c. And then we have an equal sign. A lot of times we will see a dotted line, a vertical dotted line, to separate off the terms of the equation before and after the equal sign. And the last thing we see after the equal sign is the number 1. So that's how I write the first row of my coefficient matrix. I'm going to write the second row. The first number in my second row will be -4. The second number will be 9. The third number will be 2. And then after the equal sign, we have +8. Third row. The first number is going to be -2. We do not have a B here. So in this column, I'm going to have to put a placeholder of 0 because I can't leave it out. And the next number will be 2. That's the coefficient of C. And then after the equal sign, we have 3. So this is called the coefficient matrix, and we're going to be putting this into the graphing calculator. Okay, so we're going to continue by trying to express this system as a matrix in our calculator and then put it in what we call reduced row echelon form on the calculator. So let's start with a fresh, clean calculator by clearing the RAM, second plus 712. And we want to enter a matrix in reduced row echelon form. Now there's 2 ways that we could approach this. Two ways we could approach this. We're going to do this example by one method on the calculator, and then we'll change it up for the next example, and then you can decide what you like doing the best. Okay, so the first time I'm going to just go to the matrix menu. If you'll look here in blue, you'll see the word matrix. If you'll push second and then that button, and I'm going to go over to math. You know that we have used this menu here to find the determinant of a matrix before. We're looking for something called RREF, Reduced Row Echelon Form. Don't confuse it with REF, which is row echelon form. Nope, we don't want row echelon form. We want reduced row echelon form. So I'm going to choose that. And now I'm going to put the matrix into my calculator using my shortcut menus. I'm going to touch alpha, zoom, and it's going to let me choose my numbers of rows and columns. Well, I notice that the matrix I've created has 3 rows, and there are 4 columns. So it's a 3 by 4 matrix, and that places a 0 matrix in that dimension. And now I'm just going to edit the entries by typing the numbers directly over top of the 0, and then I just use my arrow keys to navigate. And notice the calculator doesn't put that fancy dotted line. That's okay. Doesn't have to be there. Sometimes it's there in books, so that's why I wanted to show it to you. And I'm just using my right arrow to navigate to the next spot or the next row. Okay, so our calculator says RREF. You can't see it all. It puts this little arrow here to say, hey, I say more, a little bit to the left. And hit enter. Oh no, I have a big long decimal, so it's a little hard to read. But never fear, the calculator can convert this to fractions by pushing math, arrow frac, that's enter, then enter again. And oh yes, doesn't that look great? This is what we call reduced row echelon form. Now, a couple things you need to know about reduced row echelon form. One thing is you have this diagonal of 1s. If you don't have a diagonal of 1s, you're not in reduced row echelon form. Also, under the first one, there should be all 0s. Above and under the second one, there should be 0s. And above the last one, there should be 0s. The last column, well, this is where we're going to get our meat and potatoes of our answer. But this part right here should be what we call the identity matrix. The identity matrix has a diagonal of 1s, and all the other entries are 0s. The last column, however, is where we're going to get our answer. So here's what this is saying. 1x plus 0y plus 0z is equal to 1/2. 0x plus 1y plus 0z is equal to 2/3. 0x plus 0y plus 1z is equal to 2. Therefore, we can say our variable x is 1/2. Our variable y is 2/3. Our variable z is 2. We are now ready to write our solution as an ordered pair. So our solution is this ordered pair, 1/2, 2/3, 2. Or we could have actually written that x equals 1/2, y equals 2/3, and z equals 2. So this is how we can solve a system using matrices and reduced row echelon form on the calculator. Let's take a look at our second example. What is the solution to the system of equations? Again, I'm noticing I have 3 variables in the problem, a, b, and c. I want to be sure that they're in order. We have a, b, c, equal sign, then my constant. That's what I want it to look like if I'm going to solve this using matrices. A, B, C, equal sign, then constant. I don't have an A here, so I left a blank space. B, C, equal sign, then constant. These are in order, so I'm ready to write a coefficient matrix. So here's my coefficient matrix. I want to make special note that I don't have an A term here, so that coefficient is actually a 0. And I want to take a moment to put this into my calculator. This time we're going to take a different approach, but we're still going to put our matrix into reduced row echelon form. So again, we're going to start by clearing the RAM, second plus 712, just to get a nice clean, cleared calculator screen. And this time I'm going to start by inputting the matrix as a named matrix. I'm going to push second matrix to open this menu, and I'm going to go over to edit. I'm going to edit matrix A, and I'm going to state the dimensions. Well, this matrix I've created has 3 rows, and it has 4 columns. And now I'm going to input the matrix here. So I'm just going to enter all of these terms, and I'm just typing the number and then the enter button. 21, enter, and then it goes to the next row. 2, enter, -2, enter, 1, enter, 4, enter, and then my last row, 0, -8, 1, and -1. So once we put that into a named matrix, matrix A, I'm going to go back to the home screen. Second, quit. Alright, I'm on the home screen, and I want to put that named matrix in what we call reduced row echelon form. So go to the matrix menu again. Second, matrix, and we have to go over to math. And again, we're going to scroll down our list till we find reduced row echelon form, RREF. And then I'm going to put the named matrix that I created. Second matrix, I created matrix A. And I'm going to hit enter. And it puts that matrix into reduced row echelon form for me. Notice I have an identity matrix here, a diagonal of 1s. All the rest are zeros here, zeros here. Therefore, this is the solution. A is 1, B is 0.5, C is 3. Or we could say A is 1, B is 1/2, and C is 3. I could convert that to fractions by pushing math, enter, enter, and we would see B as the fraction 1/2. And then we can write our solution as an ordered pair. So this shows my solution as the ordered pair 1, 1/2, 3, or I could write that the variable A equals 1, B equals 1/2, and C equals 3. Let's take a look at problem 3. It says, what is the solution to the system of equations? And here we're looking at a system where we have variable X, variable Y, and variable Z. Notice that this one is in order, X, Y, Z, equal sign constant. The second one just has X and Z, then an equal sign and a constant, and the third one looks all messed up. So we're going to start by rewriting this to look better. The first equation is fine, so we're just going to leave that one alone. X minus 3y plus Z equals 5. Let's take a look at the second equation. We've got our X in the right spot, but we don't have a Y. So I'm going to leave a space there for the Y, and I'm going to line the 3Z up under the other Z, and then the 12. Now the third equation really kind of is in a mess. So I'm going to write it over here. Y equals -5x plus 1. The third equation has the X on the wrong side. I need this to be on the left side of the problem. So in order to fix that, I'm going to use the additive inverse, which will be positive 5x, but what I do to one side, I do to the other side. Add 5x to both sides, so that gives me 5x plus y equals, since that cancels, I've just got my constant 1. So when I write it over here with my others, 5x goes under the x's, plus y goes under the y's. We don't have a z term. So I'm going to leave an empty space here where z would be, and equals positive 1. So notice I have an empty space in the y spot here and in the z spot here. I could write, you don't have to do this, but you could write 0y in that place and 0z in this place. Now I'm ready to write a coefficient matrix. So the first row is going to be 1, -3, 1, 5. The second row will be 1, 0, 3, 12. And the third row will be 5, 1, 0, 1. And I usually like to separate that last column off. So here's my coefficient matrix. We're ready to put it in the calculator. So I've already cleared the RAM here on my calculator, and I'm ready to take this coefficient matrix and put it in reduced row echelon form. So I'm going to start by going to second matrix, and I think I'm going to go directly to the math menu this time and choose RREF, reduced row echelon form, and I think I'll put my matrix in by using alpha zoom and telling my calculator what the rows and columns are. There's 3 rows here, 4 columns, and I'm just going to type in the elements of each row. So 1, -3, 1, and positive 5. The next row is 1, then 0, then 3, then 12. And the last row is 5, 1, 0, and 1. Once you type it in, make sure that you don't have any sign errors or typos. We push enter, and that is kind of a mess, but I do notice that I've got an identity matrix here, diagonal of 1s, all the rest are 0s. This last column is kind of a mess, so I'm going to push math, enter, enter to convert those to fractions. And that tells me x is 12 over 47, y is negative 13/47, and z is 184 over 47. So here is my solution. X is 12 over 47, y is negative 13 over 47, and z is 184 over 47. This is the solution to the system of equations. So in the next example, we have 2x plus y equals 9 and x minus 6y equals negative 1. You may notice this one's different because we only have two variables, x and y. We could have solved this a few weeks ago if we had just put this in slope-intercept form, put this one in slope-intercept form, graph them on the calculator, and look for the intersection on the calculator. So we've already got a method to solve this, but I want to show you how easy it is to solve this with matrices, especially since we're already in standard form. If you're in the form x, y equals sign constant, x, y equals sign constant, it's so easy just to set up a coefficient matrix and solve using matrices. So my coefficient matrix is going to be 2, 1, 9 in the first row, 1, negative 6, negative 1 in the second row. I use this dotted line to show where the equal sign is, and I'm going to just put this matrix into the calculator. So here we go doing that. And I'm going to start by clearing the RAM, 2nd plus 7, 1, 2. I'm going to enter this as a stored matrix this time. I'm going to go to second matrix, go over to edit. The dimensions here are 2 rows by 3 columns, and I'm going to enter in those rows. 2, 1, 9, and 1, negative 6, negative 1. I'm going to go to the home screen by pushing second quit, and back into the matrix menu by pushing second matrix, and this time we're going to math. And what is it we're looking for? What is it? Is it determinant? No. RREF. What's it stand for? Can anybody in the class say it? RREF stands for Reduced Row Echelon Form. Okay, and then I'm going to go grab that matrix that I stored, second matrix. I stored it under A, and the Reduced Row Echelon Form is here. Those are really nasty decimals. I don't like them. Push math, enter, enter. Converts them to fractions, and that tells me that x is equal to 53 over 13 and y is equal to 11 over 13. So we can write the solution in this way. We can write that x is equal to 53 over 13, y is equal to 11 over 13, or we can just write this ordered pair with the x coordinate and the y coordinate. Yeah, yes. And I was planning on talking you through this real-life example of how we could use systems of equations and solve with matrices with this real-life problem. But I think the video is getting a bit long, and I can tell you guys are getting bored. So I'm going to stop here, and we will pick up with this real-life problem on another day. So I hope that this video has helped you to understand a little bit about systems of equations and how we can solve them using matrices and reduced row echelon form. So let's read our learning target again. I can solve systems of equations in 2 and 3 variables using matrices. Yay! Good luck. See you in class.